Plastics have driven much of our technological evolution. Advances in computers, cell phones, televisions have been made possible by plastics. But when it comes to recycling, there are challenges. This means we need to find new, innovative ways of using recycled plastics to extend its life. Helping explain plastics recycling in greater detail is Andrew Rubin, President of FCM Recycling.
Hello, I'm Cliff Hacking of Electronic Products Recycling Association, and we're here today with my guest, Andrew Rubin from FCM. They are a processor that looks after all kinds of electronics, but our focus today is going to be on plastics. I'm very pleased to have him with me. I'd like to introduce you to him. Andrew, welcome.
Thank you, Cliff. Thank you for having me.
It's great for you to be here. So let's start by having you tell me a little bit about who Andrew Rubin is. What have you done in your life? Where did you come from?
Absolutely. So originally was a banker, did the whole finance thing, working in Switzerland, Bulgaria, New York, into the hedge funds. Really thought I was going to have a finance career. Was fortunate or unfortunate enough to be introduced to the crash of 2008 and realized that this was definitely not for me. Made my way back to Montreal, where I was born and raised. Found my way into the green space, was always interested in it. And I guess through meeting people and seeing what great stuff provinces were doing, we found our way into the electronics recycling business. And that's pretty much, Andrew, in a nutshell. Been doing it since about 2010.
That's terrific. Thank you. So, Andrew, you're the president of FCM. I'm the president of EPRA. So together, we've got a pretty big responsibility to make sure that plastics end up being treated properly. Tell me a little bit about, from your perspective, plastics, and just start with what they are and how you think about them.
Sure. Well, I mean, in their most basic form, they're petrochemicals derived from oil, which pulling that out of the ground in itself is just a very taxing event on the environment. When we think about plastics that are in electronics, we think about more advanced plastics, much different than olefins that you would see in a milk crate or in a toy. These plastics have been built up over the years to basically replace metal, have the same structural integrity, the same qualities as metal. So when it comes to recycling these products, it gets more and more difficult, but becomes more and more important.
That's great. When you think about the recycling of plastics, there are, as you say, a number of different things in the older plastics, in the older electronics, that are of concern, and that as you bring them back in and recycle them, we have to handle them differently and be careful in how we treat them. But I'm just going to start for a minute and talk about the collection process, because from an Electronic Products Recycling Association perspective, we have across the province over 2,500 locations where you can bring back your electronics. You drop them off with us for free, and the result of that is we then take them to a processor like yourself at FCM, and they get turned back into base components that can go back into the remanufacturing process. And our percentage of recycling rate is very high. We're in the mid to high 90s in terms of what we can recover from those products. We get them, and then we send them to you, and from there, tell us what happens.
Yeah, absolutely. So those products that have been diligently collected will find our way into one of our tear down or triage facilities. We operate them in British Columbia, Ontario, Quebec, and the Maritimes. So from there, products will be triaged into how they need to be treated further, whether it be manually dismantled or prepared to be put into our shredder here on the East Coast. So when we're manually dismantling things, we'll do a very quick sort by hand. Over the years, we've learned to identify that this type of product will generate this particular material and so on and so on. So from there, what we'll do is we will bale the plastics, essentially compact them. Those are the ones from the teardown. We will move them to our facility in Cornwall, Ontario, where we will grind the material. We will remove any remaining metal. Metal and plastic don't work very well in the recycling process. We will remove any dust, any dirt, any contaminants, and we'll be left with about a 3 to 5 millimeter flake that we will then sell to what's called a compounder. These guys are like chemists or cooks, and they will take this recycled material, blend in additional requirements that a customer may have, melt it, extrude it, put it into these little pellets, and it'll eventually then make its way into the manufacturing industry. Blow molding, injection molding, rotor molding, and it's in a considerable amount of products that you will buy every day. Um, I would say that most probably we at this point are able to introduce up to 50% recycled material into virgin material to make a product which is, you know, much better than we ever saw. When we started in this industry, at best, it was 10%. And even that was a stretch. So there's been some incredible advances, not only on the e-waste side of processing this stuff, but as well on the compounding side. And of course, given the fact that we're an environmentally concerned company, we make sure that all the materials we sell, and then those materials that are further sold, remain here in North America. Unfortunately, Canada doesn't have a large enough manufacturing base to keep it all here, but we try and keep as much as we can. For the remaining material that will find its way into the shredder that cannot be taken apart by hand, we'll run through a relatively sophisticated process to remove as much metal as possible. We will be left with a commingled stream. From there, we attempt to capture as much as we can that fit into our profile. And then that procedure again will move to the Cornwall facility where it'll go through exactly the same production.
That's helpful. So if I think about the kinds of materials that are coming back to you, we'll start with something like a monitor. A monitor that sits on your desk, you hook up to your computer, it displays things. What do you get from that? What kind of plastics come out of that?
Sure. So one of the most complex things with plastic recycling is there's no standard as to what material to use per manufacturer. So one OEM might use ABS, another OEM might use HIPS, a third one may use ASA. The unfortunate reality is a lot of these plastics don't blend well together, so they have to be sorted at source. So if we take a common old CRT monitor, for example, those are mostly ABS plastic. About 16% to 18% of the monitor is recyclable plastic. They come in two variants, white or black. That's pretty much it. And some with a little bit of a yellowish tinge from age, but we're able to get the coloring out. And those are really the materials we're after. And then you have televisions, which are a wonderful source of HIPS, or high impact polystyrene, which is an extremely popular material. It's very easy to recycle, capture, and reuse, and it's a very, very in-demand product.
So when you think about ABS and HIPS, do some of the hierarchy for me of how you think about plastics, and perhaps de-acronym some of it for our audience so that they know what ABS stands for.
Sure. So ABS is acrynitrile butadiene styrene. And I'm not a chemist, right? This is just me reading it and being told what it is. Yes. But essentially, it's in its most basic form, it's styrofoam. So styrofoam is a brand name of a polystyrene, and you can inject air into it, make styrofoam. You can mix rubber into it, which known as an elastomer is how you make HIPS, or high impact polystyrene. You can put in acrynitrile and butadiene, which are chemicals that will change the mechanics of the plastic. So what we generally see is the ABS monitors, because they're smaller and they generate less heat, they're able to use ABS, which is a little bit of a less expensive material. Whereas the larger televisions generate more heat, they're forced to invest in a more rigid plastic. So it's really all the same plastic at its base, and it's just additives that are put into it to change the mechanical properties to get what people need, or I should say the manufacturers need.
Right. And so as you think then about the recycling process, you take this monitor or this television or this printer and you do the manual disassembly so that you've now got a separation of the type of plastic. From there, you take it and it then goes into this flake model that you talked about and can be reused. As you think about the hierarchy of plastics, which ones do you like best? Which ones do you like least?
Sure. So it's an interesting question. Color needs to be introduced to this, believe it or not. Okay. So the way the industry has evolved is you need to be able to process things at a fast enough pace to make it, financially viable. So the technologies that have been developed to do that are predominantly near infrared sorting. Basically, you hit it with a beam of light, and whatever chemical or light signature that gets refracted, the computer can determine what it is. So really, any type of plastic that is in the visible spectrum, i.e. not black, dark gray, we love, because they can be very easily sorted. Of course, we like the engineered resins such as HIPS and ABS, much better. They have a much better value than polypropylene or polyethylene that your milk crate's made out of. The number one for us is the high impact polystyrene, because that is a very, very excellent material that you can manipulate very well. You can turn it into styrofoam just as you could turn it into ABS. It's really a base building block. And I would say the worst thing for us on the spectrum is definitely black stuff. It looks the same, it smells the same, it feels the same, but it's probably not the same, and we can't separate it. And that unfortunately becomes a real problem because those plastics cannot be extruded together. They just can't formulate a viable product.
So what do you do with the black plastic?
Well, there are people that are more advanced than us that are able to separate this with, massive amounts of investment. These guys are taking in millions and millions of tons of this stuff a year. And they're servicing many other industries, not just e-waste. They're servicing appliances, large and small, the automotive space, which is a very big source of material from them. So we're, from an economical standpoint, it wouldn't make sense for us to put in the time, effort, and money to put in that equipment. We just don't have enough plastics generated.
Yes.
Versus kind of these guys servicing all these industries can. So that also stays in North America. There are a couple of companies that can separate it, and they basically do the same process that we do, plus the extrusion. They do it all themselves and service many of the electronics OEMs and automotive OEMs.
Now, that's helpful. One of the things that we both have in common is that we insist that products and byproducts of this are not exported to non-OECD countries, so that we're not, in essence, exporting our waste to countries that are developing. And that's a very important tenet for our organization and for yours in terms of the way we operate. So knowing that this is being remanufactured back here, largely in North America, is reassuring for people in terms of where their plastics are going to. Beyond electronics, do you get plastics back from other sources?
We do. We service other recyclers where we'll purchase their materials. We receive plastics from several appliance manufacturers. We've worked with Nespresso in the past, with Breville in the past, and we have taken plastics back from their manufacturing process that say the product didn't make it through to, sellable grade, and they couldn't fix it, refurbish it, whatever it may be. We purchase plastics from the water bottle industry, believe it or not. We've gotten a little bit into PET. We're still trying to find our path into that.
Say something about PET, because people won't understand what that means.
I don't even know. It's polyethylene tree. I can't even tell you the name.
Close enough.
It's water bottle plastic.
Yes.
So we've started venturing a little bit into that. We've also been very excited about different acrylics. So with the introduction of flat panel displays, they've switched away from glass and started using what's known as PMMA, or polymethyl micralic acrylic. Basically, it's like plexiglass brand name.
Yes.
And those have been really, really great. They're a clear resin, so you can add color to it. You can manipulate it very well in terms of its mechanical properties. So that's been a real focus of ours these days, is getting into the acrylics from all the flat panel televisions.
That's good. And when you say flat panels, I think consumers would think about things like plasma TVs, and then from there we go to kind of the organic LEDs that we're seeing these days. Which of those is something that would be advantageous for recycling?
Well, so you're 100% right. You've got the LCD, LED, and the plasma. If you want to look from, I guess, an economic standpoint, the plasmas are really the best because they have a lot of metal in them, which is extremely valuable to us, as well as plastics, and they're very heavy. And as you know, we're very much a weight-based industry, versus if you move all the way to kind of these new OLEDs that have no metal and they're very light, they're a little bit less valuable to us, I would say. But from a recycling standpoint, all three of those produce phenomenal material to be reintroduced back into the stream. They're all great.
What about rear projection televisions? How do you feel about those?
Well, I'll refrain from giving my real opinion on the air. That's a really difficult television to deal with, and it's got several components to it that are not great. So first of all, a lot of these have a wood frame, and unfortunately, wood is not really easily recycled when it's been sitting in someone's home for 30 years. It may have moisture in it. Who knows? So that kind of has to go into, waste energy, which is not great. Then when you pull out the little projection bulbs, there's generally three of them. In it itself, it's like another little CRT TV. So you've got leaded glass and you've got aluminum, and then you have this wonderful, glycol that's just everywhere. And, you don't want to spill that on the floor because it'll turn into a skating rink. So those have to be taken apart in very special areas and very specialized workstations because, the risk to employee health is significant there. You have glass you can be cut on. There's this glycol that is really not great. So I really don't have anything positive to say about them. I could say, thank God they're not making them anymore, but we're able to recycle them 100%, but they have no real viable plastic for us.
And that's one of the things that I think is probably an evolution in terms of the electronics industry, is that we've gone from the CRTs, the cathode ray tubes that you described earlier, which had leaded glass in the front of the screen, and so capturing that lead back out of the glass is something that the entire industry is implicated in. We end up taking that lead basically and turning it back into ingots so it can be reused in terms of a recycling process. And similarly, as you say, probably fortunate that the rear projection TVs are a thing of the past as well, because that ethyl glycol is almost like antifreeze in a way, and it's something that you have to capture separately, which can be reused, but we don't really want that into our environment either. So all of that becomes part of the recycling process that your organization does beyond even just plastics. Now, as you think about the evolution and you talk about the last 10 or 12 years of what's happened with electronics, we've seen a real evolution, and you made a reference to this earlier, towards more and more plastic in products. It's lighter, it's easier to ship. You've talked about the durability factors. What percentage would you say of the electronics that are coming back have plastic as part of them now? And how much plastic do you think you're getting compared to what you used to get 10 years ago?
I would tell you 100% of electronics have some plastic in them somewhere. There is nothing that we have ever seen that's just metal that's still in its whole form. I would say probably 10 years ago when I started in this business, on the manual teardown side, it was about 10 to 12% plastic, and on the shredding side, we were probably around 18 to 20%. We fast forward today, where lightweighting is a big trend. Plastics are much more easily manipulated by manufacturers to make these, very nice, very sleek designs. I would tell you on the teardown side from the flat panel displays, those can get up to about 60% plastic. And on the shredding side right now, we're probably sitting 30 to 35% plastic. A significant jump. It's very noticeable.
So when you think about the industry, the trend towards more and more plastic is something that has caused that focus for your business to be critical to the success. And it's also something from a societal perspective that we need to be aware of, because recycling those plastics is terribly important for us in terms of making sure that we're looking after the environment, that they're not going to landfills, and that those kinds of things are being done. Do you see a trend of this increasing over the years? I mean, if you were to project 5 years out, knowing no one has a crystal ball, what would you think will happen in terms of this plastic space?
I think that there's starting to be a lot of focus on it, and I would say there's been a significant uptick in focus on the environment and the world's climate in recent years, and I would expect that trend to continue. And plastic has been a real big focus with the amount of pollution that people are seeing in the ocean. These microplastics, or they'll put them in various face creams for abrasion that are now starting to turn up in the wastewater system, even in people's blood. So I think it's becoming a more and more important focus, not only in electronics, but basically plastic all around. And I think that that's led to some very good investment in the industry, which has gone towards technology to clean and separate material streams that wouldn't be capturable in the past, or wouldn't be financially possible because the amount of labor required would put it as such that the intrinsic value is far less than the cost. So I think that we're going to see a lot of great sorting technology coming out to be able to better separate and recycle this. On the counter side to that, one concern that I have is as plastics evolve and they get more and more complex, and they take on more and more of a role that metal had, we're going to see new introductions of various petrochemicals that we may not know how to recycle right now. And I would say one of the biggest shifts has been these OLED TVs, or non-metal conductive circuit boards. These resins, we as recyclers don't know anything about them. So there will be a learning curve. We will have to figure out how to recycle those. We don't know how they will react. So that's been a concern of mine. So good sorting on the way, but also new products we have to learn and figure out on the way.
New challenges to go with them.
As always.
Which is the way life goes these days.
As always.
When we talk a little bit about the sources of plastic, you made reference to the fact that it's a petrochemical base. When I think about somebody who's doing a manufacturing process, why, from an economic perspective, would they want to use recycled product versus virgin product?
Yeah, absolutely. Well, the first and most basic of it is it's cheaper. Virgin material sells at a significant premium to recycled material. It's obviously always the first step. And number two is, I think people are waking up that if we continually produce plastic, and this is not something that's mined, we produce it. We can make as much of it as we want, right? We don't, there's no finite amount of it. As we continually process or create plastic and just kind of throw the rest of it in a landfill, it's going to be a serious problem. Some of these plastics will survive thousands of years before they break down. And when they do eventually break down, it's a nasty slew of stuff that's going to be moving its way into the earth. So I think that population or the public has pressed these manufacturers to find more green alternatives to their production. So I think that they're doing that as well to satisfy their customer base, and hopefully a customer will choose the green product over the not green product. Obviously there's the cost. And I think that as the export destinations such as China or Africa, Malaysia slowly start to realize that, hey, we're not a garbage dump, and they begin to close their ports to this, there becomes a need to process it here because there's just nowhere to put it. And so, God willing, they'll have export bans on all this waste, and the cost of landfilling things will go up, and people will be in a position where it now makes financial sense to recycle the material. That's what I'm hoping for. But yes, it's definitely becoming more and more important to the manufacturer.
Well, and one of the, so there's a couple of points you've made there I'd like to touch on. One of the important things from a Canadian perspective is that we do not export products or waste to those countries overseas. The United States perhaps doesn't have quite the same record with respect to that, but we do deal with a number of our problems here in country, which is a credit to Canada in terms of the way we operate. The other thing that I was wondering is we've talked earlier in some of our earlier discussions regarding metals and the fact that there's about a 10 times factor for what it costs to mine metals versus recovering those metals in the electronics cycle. So it's cheaper by that kind of a factor, a 10 times factor. What does the factor look like roughly, and knowing that markets change all the time, but what does it look like from a plastics and an oil perspective?
The unfortunate reality is, while it is considerably cheaper to use recycled material, it's not, and we're talking about in terms of millions of pounds where a penny or two can really make a difference. The cost factor is not as big of a delta between recycled and virgin as it is in metal. So while it is cheaper, no doubt, you run into logistics problems such as moving the stuff around, transporting it. There overall is less of an infrastructure to recycle plastics than there is metal. It's easier to get into. You can see that this is clearly a piece of steel. The magnet works. You see this is copper by the color. Okay, I can figure out what this is.
Sure.
You hold two pieces of plastic, unless you're trained, and even trained people are kind of looking at it, it all looks the same. So it's harder space to get into. There's less infrastructure to bring your material to, which means it has to be transported around quite a bit, which kind of adds to the cost of recycling. So I would say, in my personal opinion, is if we could find a way to have more hubs localized to process this stuff, we could significantly reduce the cost of recycled plastics, and we could widen that delta to make it even more interesting
attractive
to use it. Yeah,
sure.
There is a considerably big delta between plastic and metal, and obviously there's also the concept that metal is finite, right? Whatever we've got in the Earth's crust is what we've got. Maybe one day, SpaceX will be mining asteroids, but until then, we've got a finite amount. In terms of plastics, we can virtually produce as much as we want. So there's no even worry to start planning ahead now and start conserving the material.
Okay, so it gives us a different motivation in terms of why we need to recycle plastics. Still important for us to do so, whether that's the plastic bottles that we see less of these days, or the electronics that we're talking about here. And helpful to know that that delta is there. One of the things that I would say, and we've seen probably in the last 5 years, is this progression with respect to plastics being recycled here in North America. And your company is one of the first to have done that. There are a couple of others who are in this space as well. And so it is, in many regards, kind of either a re-entry or an introduction altogether of recycling of plastics. I mean, I think if you go back maybe 20 or 30 years, you would have found there would have been some plastic recycling going on. As you say, much simpler chemistries back then in terms of what they were dealing with. So while it's more complicated now, it's also more necessary for us to be able to recycle those plastics. And as I think about all of that and say to myself, here we have a bunch of different industries all generating plastic, needs to have a home. You've been able to put in place, whether it's here in Ontario or whether it's across the rest of the country, the opportunity for us to be able to get those plastics out of the supply chain, the reverse supply chain, and get them back into the remanufacturing process. So that's a real credit to FCM and the work that you've been able to do.
Thank you so much. I appreciate it. And, as I explained, it's this collection network and transport that makes plastic very difficult to recycle. And it's thanks to EPRA and all the depots that they have making it, feasible for the public to bring it back, that we've been able to source enough material to get this done. So I would thank you as well.
Well, I've really enjoyed our conversation today, Andrew. Thank you for that. A welcome diversion is something that we have enjoyed bringing. We want to make sure that the future is in your hands, so don't let it go to waste. And we very much look forward to future conversations, and thank you for joining us.
Thank you so much.
Welcome Diversion is brought to you by EPRA Recycle My Electronics. To find the location nearest you, visit recyclemyelectronics.ca. The future is in your hands. Don't let it go to waste.